After watching the video LiDAR Scanner Essentials, Multi-Scan Alignment in CloudCompare tutorial by Payo-TensileCreator, see the link below. I thought, CloudCompare is a great program, but sometimes a bit cumbersome to use. This should be able to be simpler, was my thought. So, welcome to the CloudAlign 1.0 tutorial. CloudAlign is a small free-to-use, focused Windows app built for one job, taking several separate LiDAR or photogrammetry scans and lining them up into one clean, correctly oriented point cloud. No unnecessary menus, no steep learning curve, just import, align, and export. Let's walk through the whole process, start to finish. Before we import anything, a quick word on the viewport itself, since we'll be using it constantly. Left drag rotates the view, scroll zooms in and out, and right drag pans around. If you select a cloud in the list on the left, Shift plus left drag moves that cloud, and Shift plus right drag rotates it. Arrow keys nudge the selection sideways. Control plus up or down changes height, and Shift with the left or right arrow rotates it too. There's also a clip box you can toggle on, which lets you isolate just the part of the scan you're working on. Very handy once we get to picking floors and walls. Dragging one of its arrows resizes the clip box from that one side. Hold Alt while dragging, and it resizes from both sides at once, keeping it centered. All of this is also listed in the built-in manual, so you never have to memorize it. We move to the Alignment tab. One tip first. With several scans loaded, it's best to hide the others and work with only the reference scan visible. That keeps the view clean and makes sure you're picking points on the one cloud everything else will be measured against. Here, only Floor 1 is checked. Floor 2 and Floor 3 stay unchecked for now. We start by squaring the model to the axis, so the whole scan lines up neatly with the grid instead of sitting at an arbitrary angle. First, we make a clip box and isolate a clean, flat section of wall. Picking on a busy scan is much easier once the clutter around it is clipped away. Next, we switch the cloud to a single, solid color instead of RGB. With a flat, uniform color, the wall surface stands out much more clearly, so it's easier to see exactly where you're clicking. Only then do we click Pick Wall and select points on that surface. CloudAlign snaps the whole scene square to the axis in a single click. In this case, we start with the Y-axis and optionally follow up with a second wall along the X-axis for extra precision. With the walls square, we level the floor because almost every scan comes in slightly tilted. We narrow the clip box again, this time to isolate a clean patch of floor, then click Pick Floor and select 4 points on that surface, spread out around the room for accuracy. Watch out for obstacles on the floor here, like furniture or debris. A point picked on top of something instead of the floor itself will throw off the whole calculation. CloudAlign calculates the floor plane from those 4 points and levels the entire scene to it in one click. There's also an auto-level option if you'd rather skip manual picking entirely and let the software estimate the floor for you. With the reference scan leveled and squared, it's time to bring the other floors in one at a time, not all at once. For each cloud, we follow the same 3 steps. First, we place it roughly by hand. Select it and drag it into position in the viewport and rotate it. Then we give it a unique color, so it's easy to tell apart from the other clouds while we work. And with that color making it clear which points belong to which cloud, we fine-tune the height until it's sitting approximately where it belongs relative to the reference. Second, we use the clip box to isolate just the overlapping section between the 2 clouds, the part they actually share, so the next step has clean, relevant data to work with instead of the whole scan. Third, we switch to the Registration tab and let CloudAlign do the fine alignment automatically. Watch the match percentage climb as it fine-tunes. Here it locks in at around 78, then 81% overlap after a few dozen iterations. Once that cloud sits well, we move on to the next one and repeat the same 3 steps. Rough placement, isolate the overlap, then let registration finish the job. At the end of that 3rd step, we use Clear View to reduce the density on screen, so we can see straight through the point cloud and properly check how well the 2 scans actually line up instead of just trusting the percentage. Keep an eye on the match percentage shown next to each cloud in the list on the left as it climbs, from a rough first pass to a solid 78, 80% overlap. The outlines are converging wall for wall, corner for corner. This is the point where most of the manual guesswork other software requires simply isn't needed anymore. You're not limited to one cloud at a time either. Here you can see multiple point clouds selected together, moving and rotating as one group, useful when several floors need the same correction. You can even place a custom rotation point anywhere in the scene, great for rotating a cloud around a specific corner or feature rather than its own center. Switching to a 3D perspective view like this lets you judge the alignment properly. From directly above, small height differences between floors are easy to miss, but from this angle any misalignment stands out immediately. A few more nudges, and the floors are locked together as one coherent structure. Once you're happy with the alignment, it's time to save. CloudAlign shows a quick progress bar while it writes the point cloud data. For large scans with millions of points, that can take a few seconds, and you'll see exactly where it's at rather than wondering if the app has frozen. There are two ways to export. The first, shown here, exports everything as a single, combined point cloud, merging all the aligned scans into one file. The second option exports the 3-point clouds as separate files instead, keeping floor 1, floor 2, and floor 3 apart. Handy if you still want to work with each floor individually afterwards. Either way, you choose your output format LOS, PTS, or XYZ, whichever fits best into the rest of your workflow, whether that's another point cloud tool, a CAD package, or a custom pipeline. Your aligned clouds are saved exactly as you position them, ready for the next step. One more thing worth showing. CloudAlign also saves its own project files, so you're not forced to redo this whole process every time you open the app. Here we're loading a previously saved project, 3 floors already aligned, straight back into the viewport in a top-down view, points loading in progressively. That's done through a regular Windows file dialog. You simply browse to your project file. Everything you did in alignment, registration, and manual adjustment is remembered exactly as you left it, so you can step away and come back later without losing any work. Last stop. The settings panel, open from the gear icon in the top bar. Here you can switch the interface between English and Dutch, choose whether distances are shown in meters or millimeters, and pick a light or dark theme, dark, in this case, which even carries through to the Windows title bar. There's also a display quality toggle for balancing sharp rendering against smoother performance on very large scans, and an optional performance overlay if you want to keep an eye on frame rate and point counts while you work. All personal preferences, and CloudAlign remembers them the next time you open the app. And that's the complete CloudAlign 1.0 workflow. Import your scans, square the walls, level the floor, bring in each additional scan with a rough placement, an isolated overlap, and automatic registration, fine-tune by hand where it matters, and save or export whenever you're ready. One straightforward tool without fighting the software to get a clean, aligned point cloud. Thanks for watching, and I hope this saves you as much time as it saved me.